Hello there. In this lesson, we're going to learn about current electricity. Current electricity is different from static electricity. Static means stationary, you're staying still. Current electricity is when the electrons are in motion, and electrons have to travel through circuits in order to be in motion. So we're going to learn about that. And then we're going to look at some of the sources of energy that are used to get electrons to flow through circuits. So a couple examples here. Anything that's plugged in the wall is connected to a source of energy that's going to cause electrons to flow. Anything that has a cell or a battery in it uses a chemical reaction to get electrons to flow. And you've probably seen these as well. Solar cells work the same way. They just use radiant energy to do the same thing. All right, so in order to get electrons to move or to flow, you need the components of a circuit, which means you need wires and you need a power source. And so the power source is going to get those electrons to flow. It'll flow through some wires, and then there'll be some device that uses that electrical energy. So the power source provides energy, and the load uses energy. And then the electrons have to complete the circle, and come back to the power source. So they leave the power source with lots of energy, they use it up at the load, and then return to the power source. So all circuits have some variation of this in order to get the electrons to move. So devices that use electrical energy are called loads, right? Here's some examples of loads. This is a light, obviously, and so it converts electrical energy into light energy. This is a fan, which turns electrical energy into motion. This is an electric piano, which turns electrical energy into sound. And this is a kettle, which changes electrical energy into heat. So all loads convert electrical energy into some other useful form of energy that we use in our everyday life. Cells and batteries are one way of providing the energy that's going to be used in the circuit by the load. So electrochemical cells are just what they sound like. They have chemical reactions inside that produce the movement of electrons, right? And so you might call these batteries. A battery is really when you have more than one of them stacked together. And so you have cells that have a chemical reaction that only can be used once, or you can have a secondary cell that is rechargeable. So more and more we have these in a lot of our technologies, and they're a little more environmentally friendly because you don't have to throw this on a pile and bury it under the ground. So secondary cells are a little more efficient that way. And then if you put more than one of them together, you got yourself a battery. This is a battery. It's part of a television remote control at my house. And so chemical cells are a part of a lot of devices that we use every day. Some other cells that you might have seen or heard about. One is called a fuel cell. Fuel cells are just like electrochemical cells, only you can keep adding more of the chemical. So in a battery of electrochemical cells, like you have in the remote there, there's a certain amount of the chemical inside that's needed, and once it all reacts, then the reaction is done. With a fuel cell, you might use something like hydrogen, where you can continuously add it, and then that electrochemical reaction can continue and produce electricity for something like electrical motors. So some fuel cells are used in things like city buses and some other vehicles to provide electricity for their electric motors. The good thing about hydrogen fuel cells is that the exhaust or waste that they produce is water, which is already naturally occurring in our atmosphere, and so doesn't cause any more of the climate change stuff that we're seeing these days from other sources of energy. Another type of cell is the good old photovoltaic one, and these convert radiant energy or light energy directly into electrical energy. So these are pretty awesome too. You'll see some people have these on their homes. to provide electricity to the home or to the grid. And so there, hopefully we'll see more and more of those integrated into devices to provide energy for the loads. The type of energy that all those cells produce, whether it's the fuel cell or the electrochemical cells in a battery or the photovoltaic cells in the calculator, all produce electricity that flows in one direction. It always leaves from the negative terminal, and then it's going to go through whatever the load is here, and then in this case it's a light bulb, and then it has to return to the positive terminal. And so when that is the case, the electricity is said to be direct current, which means it only flows in one direction. And so all devices that have cells run on direct current or DC power. A second type of electrical power source uses what's called a generator. So an electrical generator, you might have seen something like this before, will have something that turns. So in this case, it's a little crank. And then inside the device, there'll be coils of wire and some magnets. And the movement of the wires next to the magnets produces an electrical flow. It produces the energy needed to get electrons to flow through a circuit. So the trick is then to find a power source that will turn the turbine to generate electricity this way. So there's some natural ways you can do that using energy from the environment. So falling water, if you go to Niagara Falls, there's a bunch of hydroelectric power plants there where the water flows over a drop, and the drop turns the turbine, generates the electricity, and then flows out the bottom. So this hydroelectricity is great where you have places like that where the water is flowing over a drop. There's quite a few places like that in Ontario since we have lots of water. If you live on a coast, you might use tidal power. So tides go up and down twice every day, and so if you're at a place like in the eastern part of Canada where there are some pretty big tidal shifts, you can use that to turn a turbine and generate electricity. And one that we've seen quite a bit in the last 20 years or so is wind turbines. So there's places all around Ontario where pretty consistent wind, and you can use the wind to turn the turbine and generate electricity using a generator. The other type of place where you can use generators is where you have a heat source. And you can use a heat source to boil water to make steam, and steam under pressure can turn a turbine and generate electricity. So some of these are renewable and some of them aren't. So if you use nuclear power, so you have a nuclear reaction here, the nuclear reaction will produce a lot of heat, and that heat will boil water and turns water from a nearby source like this. You'll take some cool water from a nearby source, and then it goes through the boiler and it becomes steam. So the steam is under a lot of pressure. So after you have this pressurized steam, you can get it to turn your turbine and generate electricity. Out comes the electricity. And then you release the water, and it cools down back in the river. So nuclear reactors have, some of the drawbacks. Every so often there's an accident and some nuclear waste gets released into the atmosphere or into the water nearby. So there are some drawbacks to it. Plus there's a limited amount of nuclear material. So it's not considered a renewable resource. Some other ways that you can use this same system, just cut out the nuclear reaction, you can use biomass. So some places where there's lots of, say, wood chips or leftovers from crops, you can burn that, and that will generate the heat to make the steam turn the turbine. Fossil fuels, of course, this is probably the original way of doing this, would be to take some coal or oil and burn that, and that will be your source of energy to make the steam to turn the turbine. A cool one, if you ever go to Iceland, is they use geothermal energy to produce electricity. And it works the exact same way. Just use heat from under the ground. That's what geo means, as earth. So geothermal, heat from under the earth, and use that to boil the water, make the steam, turn the turbine. And finally, a place where you have a lot of sunlight, you can use the heat energy from the sun. So there's a couple places in the world where this has been used. Places like in the middle of the desert. I think there's some in Iraq and some desert places in Africa where they have like intense sun, 300 days out of the year, and so you can use that to heat. Usually they superheat some oil, and then that oil is used to boil water, make steam, and turn a turbine. So they all work pretty much the same way. Some of them are renewable, right? So geothermal would be renewable. You're never going to run out of that. Biomass is renewable as long as you keep growing crops. Solar thermal is renewable. And some of them are non-renewable, like the nuclear or the fossil fuels, because there's a limited amount of those things and we'll eventually run out. Electron flow from a generator is different from that of a cell. There is a flow from negative to positive, which is just like from an electrical cell through a circuit. But from a generator, the electrons are always switching directions. So the side that's negative doesn't stay negative for long. And so dozens of times each second, the direction of electron flow switches. And so it's constantly flipping back and forth. This is a very efficient way for transmitting electrical energy down wires and long distances, and provides all the energy for any device that you would have plugged in. So everything in our home runs on this alternating type of power called alternating current. If you have a device that has a cell and you can plug in, like this computer here, so inside the computer there is a rechargeable battery, right? So that means that the device runs on direct current power. But then when you plug it in, it plugs in, it runs on alternating current power. So whenever you have one of those things that is going to be using both types of power, you need a converter. So on the plug, somewhere between the wall where it plugs in and gets AC power and the device that uses DC power, you'll need a converter to switch from one type of power to the other. And so those chunky plugs that you use to charge your phone, they all have little converters in them to change the type of electron flow.